Hello, welcome to the notes on chain rules. So this is our last bit of derivative rules we'll look at, and I wanted to start off looking at the chain rule with different ways we could possibly take these derivatives without any new rule. So if you were asked to take the derivative of a through d here, could you do that? And the answer for these first three are yes. Yes, you could. You'd have to multiply it out first, and it would just take increasingly more time to multiply out 2x plus 5 to the 6th and so on. And then you could take the derivative with the power rule. That's great. So we're not actually going to do that. However, if we go and look at this one over here, d, we don't, sure, we could write this as 2x plus 5 to the 1/2, but we don't have a way to conceptualize what the derivative of a group is, given that that group has a fractional exponent. So if that's what we're trying to accomplish, then that's not so great. And even here for C, this one is still, like, I would not want to do that derivative. I would not want to sit there and multiply all that out and do that. There has to be a better way. So that's what the chain rule is going to help us accomplish. And the chain rule here is expressed in a few different ways. And perhaps the easiest way to look at it is through this definition down here. The most critical part about this definition, and it's, I hope you have a different color, or at least a pen and a pencil or something like that, is being able to recognize the existence of a function within inside a function. So if I'm taking the derivative of a function inside a function, so I'm going to use pink and blue, so g of x is inside f of x, then we will always take the derivative of the outside function while leaving the inside function, no derivative on it or anything like that, and then multiplying that by the derivative of the inside function. So we're chaining derivatives together. Go from one, leave the inside, to the other, to the inside, to the inside derivative. So this little key down here is the best way to think of the chain rule right now. With that, we're going to look at this first example. So without chain rule, 2x plus 5 squared has to be multiplied out. So we need to rewrite it first. I get 4x squared plus 20x plus 25. And then I can take the derivative. 8x plus 20. Nice. And then with the chain rule, I want to make sure I write this down so we can see everything. F of x is going to look like, I am going to use different colors here. F of x is going to look like something with an inside function and an outside function. So our outside function is that thing squared, and then the inside function is 2x plus 5. So I'm not going to recopy this formula. I'm not going to recopy that, but I am going to have that in the back of my head. So, I mean, we've done so many of these rules through the practice already that I hope that this becomes just ingrained in the process for you. So if I'm actually finding f prime of x, I don't want that color, f prime of x, then I take the derivative of the outside thing. So the outside thing is 2 with something inside of it. So 2, and I leave that something inside of it to the first power. And then times that something on the inside, times the derivative of the inside, which is just 2. And I like to leave parentheses there so I know I have operated correctly. Now, there is some discrepancy here between the answers. The 8x plus 20 and the 2 times 2x plus 5 times 2 need to look the same, so we're going to do that real quick. And that just takes some multiplying out. So I have 4x plus 10, and that is going to be 8x plus 20 when I multiply by 2. Alright, so that one, in that case, in example 1, it might be a lot easier to not use the chain rule for something that's just 2x plus 5 squared. When we get into cubing something, that's when things get a little bit trickier. So I'm going to do this, and I'm also going to do the chain rule and then come back to you. Alright, so here we are. We're at the last steps for each function. So I wanted to show you what multiplying this f of x out would look like, and then actually taking the derivative looks like 24x squared plus 120x plus 150. So that means if we did the chain rule correctly, then we should see the same thing once we multiply it out some. So I'll have 3 times 4x squared plus 20x plus 25 times 2, and that's going to give me a 12 times 2, which is 24x squared, boop, boop, and then a 60 times 2, which is 120, and then a 75 times 2, which is 150. So that will give me the same answer as what I found there on the left. So this one's kind of in between. It's sort of rough either way. You've got to multiply out a cubic and then take the derivative. That part seems kind of easy, but then simplifying here after taking the chain rule is just a little bit of a task. You have to multiply out a binomial squared. So we know that they're equivalent just based off what we found. So that's another example for the chain rule. Now 3 and 4 are definitely examples that require us to use the chain rule. If we don't, then we'll be sat here multiplying for a while. So here, f, we can just drop straight into the chain rule with this one. F prime of x, because we know that, I'm going to use pink coloration and blue again, we know that that pink thing to the 10th power is the outside. Then I'm going to take the derivative of the outside first. So 10, oops, to the 9th, 10 pink thing, so 2x plus 5 to the 9th, and then times the derivative of the inside, so times 2. Luckily, we're using the same inside function every time, so we can see how that remains the same. And at this point, the only thing we can really do to make this look better is just say that it's 20 times 2x plus 5 to the 9th. So that's f prime of x. For example 4, we do have to do a little bit of rewriting before taking the derivative. And I'm going to try this time to not show the group. So f of x is equal to 2x plus 5 to the 1/2 power. So here's the one that we just couldn't even do before. And now with the chain rule, we know that we'll take the derivative of the outside function. So we've got 1/2 blah to the negative 1/2. And notice I'm doing the power rule on that outside piece before I just put my variable 2x plus 5 inside. Because we would, if this were, yellow scribble, what's the derivative of yellow scribble to the 1/2? You would say that's 1/2 yellow scribble to the negative 1/2. But because we have something specific, we'll use that. And let's just say we keep it yellow scribble on the inside. This would be the derivative of yellow scribble on the outside, because that's the derivative of the inside. That would really show some understanding of the rule if we did some abstract math like that. But since we have these clear numbers, let's just stick to that. So the derivative of the inside is simply 2. Okay, so not so bad. We're just using the power rule. Now for 5 and lastly 6, we have to kind of use some exponent knowledge, especially for 5. On 5, y is equal to this fraction. And you might be like, well, let's just use the quotient rule and be done with this because we got a numerator and denominator. We can actually rewrite this to 4x minus 3 to the negative 1. Because this group in the denominator has a first power, so we can just write in the numerator with a negative 1. So that means y prime is equal to negative 1 times 4x minus 3 to the negative 2. So keeping with the power rule derivative, we'll be just reducing the power of negative 1 by 1. And then times the derivative of the inside, which is 4. Okay, and I'm sorry, I didn't simplify these last two. There's really not much we can do. We can't distribute this, we got 1/2 times 2 up here, back at example 4. 1/2 times 2 is just 1, so this is just 2x plus 5 to the negative 1/2. There's not much to simplify, and you can't write this in a simpler form. We're going to leave the negative power there as well. Same for this one, so I have negative 4 times 4x minus 3 to the negative 2. Alright, and then I'd like you to try example 6 to see what you get. You can pause, and then once you do, you can resume. So this one's going to be y prime. There's no rewriting necessary. 3x squared minus 2x plus 1 squared, and then we've got just a little bit more to write, just a little bit more to take the derivative of on the inside, which is going to be 6x minus 2. Yay! There we go. So that's the derivative of that, and if you want to simplify it just a little bit, I think this is the best option to take. So it would be 18x minus 6 times 3x squared minus 2x plus 1 squared. So yes, this can be multiplied out a lot more, but for the sake of multiple choices and having to type everything out, we're not going to do all that multiplying. So at any point in this, you should be comfortable with finding the answer if it were multiple choice. Just because if you see the answer maybe multiplied out like it is in 2, then you know you'd have to multiply it out some. So you'd have to be able to recognize that 3 times this trinomial times 2 is the same thing as this trinomial with different coefficients, which again is just multiplying out. So we can talk simplifying in class. But for the remainder of the worksheet, we probably won't get to them here in the video. We'll talk about them in class. So thanks for joining, and I'll talk to you later.